Welcome back to Pre-Calculus with Miss Nieskerin. And today we're going to be talking about composition of functions. Composition of functions. And I'm going to introduce it through a scenario. And then we're going to take it through graphs and tables and algebraically. So we can show you the different methods where it shows. So right now this is the verbal method. Now, every time we do something with a word problem, we really are trying to tie it into the real world as best as we can. Sometimes we kind of make it up to make the math fit, to make a real world scenario so we can kind of catch your attention. And sometimes it's just there. It happens, just like this in the scenario of temperature conversion. You may not think of it as a composition of functions, but it really is. So let's read through this. A pharmaceutical researcher has completed an experiment which involves measuring the temperature of a chemical reaction after 30 seconds. The thermometer she has reads only in degrees Fahrenheit, and the temperature was 183 degrees Fahrenheit. However, her lab manager requires the report to use the units of Kelvin. She knows how to convert from degrees Celsius to Kelvin, and she remembers a formula for converting degrees Fahrenheit to degrees Celsius. She also then asks her boss to buy her a thermometer that actually reads in Kelvin, so she doesn't have to do all that extra work. So we have to kind of sort through this. So one of the important things is we saw that it was after 30 seconds. We saw that the thermometer she reads only in degrees Fahrenheit, and the temperature, or initial temperature, was 183 degrees Fahrenheit. And she has to use the unit of Kelvin. She knows how to convert from degrees Celsius to Kelvin, and she remembers a formula for converting degrees Fahrenheit to Kelvin. So all of that is really the important stuff. So we have to figure out what she's got. Well, she's got her tables for us, so we're going to kind of take a look at the tables. And we see that the tables say C of F, Fahrenheit degrees, Celsius degrees. So this looks like I'm taking the input of degrees Fahrenheit and putting it into a function that outputs the degrees Celsius. I also see what looks like KFC. I'm so glad we didn't do this the other direction because I'm thinking chicken and I'm hungry. But anyway, it looks like KCF, and it's really weird. But what's really happening is we have K of C. We take degrees Celsius as our input, and we end up with, when we get done with the function, degrees Kelvin. So, of the important information we had, 30 seconds, that really wasn't that important. Everything else was, especially the starting temperature. So I'm going to start using some color coding. So the degrees Fahrenheit is going to continue to remain blue. Excuse me, sorry. So the degrees Fahrenheit is going to continue to remain blue. I can see here, so I'm going to take and color code all my F's. So wherever I see degrees Fahrenheit, I'm going to color code it like so. And so all of this is actually blue, that whole table. Okay. Degrees Celsius is going to be my output. I'm going to call that red for this case. But notice that red is now input. That's interesting because it's going to become an input for the next function. This is the idea of a composition. So we're going to call degrees Celsius where we are. Everywhere I see degrees Celsius, I'm going to color code that in red. And that looks like hot pink or orange, but it's red on my sheet anyway. So whatever color you see it is, that's fine. And the last thing we're going to do is we're going to grab that Kelvin. And I'm using pencil here just because I, only had the two colors. And so I'm going to color code Kelvin. And so I see this entire table is going to end up being red. And yeah, I know you can't see it. Don't worry. You're going to see it in a second when we get there. And then the whole table for the Kelvin output is going to be pencil. And so we said she started with 183 degrees Fahrenheit. And she has to convert that temperature to something Kelvin through some means. So we're looking through the table. Let's see if I can bring up my whole table. I can. Yes, I've got what I've started with. So I come down in the degrees Fahrenheit and I find 183. And when I take that 183, it becomes this value here as an output of 83.9 degrees Celsius. But that's still not what the requirement is. The lab requirement is that she has to take that value and she has to find it and convert it to the final answer. So this is our full mock-up of what she did. Her 183 degrees Fahrenheit became 83.9 degrees Celsius, which then became 356.9 degrees Kelvin. And what she did was she took the input, put it into the function, it did its magic, and it came out with the output. She then took that output and made it become the input. So that's new. And we're doing a second step. And she put that now output, which is now input, into the function, and it did its magic and came out with this as 356.9 in Kelvin. Well, that's what it looks like when we do it numerically or a table. What happens if I look at it in terms of graphs? So here's where I'm wishing I had my school issued ID, because when I go to graphs, she has the graphs for us. And the graphs told us she had degrees Celsius, which started out, degrees Fahrenheit. I circled that in the wrong color. Degrees Fahrenheit. She finds 183. So tiny, tiny numbers. I want to make sure I got that right there. And it goes up to the graph to that point. And once I find that point, gotta rearrange my pens here. This is going to output my degrees Celsius, which is what that should have been that color. Sorry, I did not mean to make that mistake. And when I come out, again, my school issued straight edge would have helped me out here to keep this straight. I end up with this. Well, the problem here is can't really read it. So every time you guys tell me, hey, I want to use graphs, I get it. You guys, one, don't understand graphs in the first place, which is kind of hard because we need to start getting used to graphs because they're everywhere. But at the same time, we also don't see the number. I have to guess. I know it's 83 point, and it's really close to 84. So I'm going to come back over here with my degrees Celsius because that output is now going to be my input. And I'm going to go to a little bit above 84. So I'm somewhere in here. And I'm going to take that straight up as best as I can without my school issued straight edge. I'm so sad. All right. I had it. I packed it, I thought. And then that point on the graph translates to our new value over here. Which again, I'm still going to have, it's somewhere between 356 and 357. And I'm going to guess it's, 356.9-ish. I know that number because I had the table. All right. This is why we do things algebraically a lot. Now, the problem is this algebraically, scary. So all we're going to do here is we're going to do some color coding, and then I'm going to do one fancy writing thing that I kind of wished we had here. We started with degrees Fahrenheit, so everywhere I see the F, I'm going to color code that blue. Everywhere I see the F, I'm going to color code that blue. So these are my separate functions. This was basically, I am going to write the word here, table 1. And this was table 2, which I probably should have numbered over here. So we're going to do that real quick. Table 1, table 2. All right. And this F went into the C function, and it came out as a C value. and it went into the k function as an input. It goes into the k function, so it's input. And I don't see it at the end. That's the idea of an entire composition of functions. And then I end up with a k function. So ultimately what I have at the end here is k of f, because I've kind of simplified all of that down. So this is just your brief introduction to composition of functions. But I am going to write one more thing. I'm going to write in pencil, and then I'll color code it. I'm going to write k composed of c of f. This is a composition of functions. This is equal to k of c of f. And so this is how we write it succinctly as mathematicians. We still have our full input, which is what I really started with, which goes all the way into the inside. Goes all the way into the inside. So that's inside all of that. Inside all of that. And it became a part of the C function, which was then the new input for the next function. So it was output, it became output for the C function, but it becomes input for the K function. And that is a real quick introduction to composition of functions. Thanks, guys.